If we start with Chapter 8, and we're going to go through one of each kind of hypothesis test through Chapter 8. Then I'll go through one of each kind of finding a critical value. Then I'll go through one of each kind of hypothesis test for Chapter 9. And hopefully that'll help set everything in your mind about how to tell the difference between these. First, we read the problem. And these are problems that I just took from other worksheets. And I just chose them because it gives me one of each. But the USDA reports the mean cost of raising a child from birth to age 2 in a rural area is $83.90. The first thing I notice is that it says mean cost. So once I know I'm talking about means, I need to consider, can I even work the problem? And if I can, is it a Z or a T? So to figure out whether or not I can use the problem, I kind of scan the rest of this. I'm looking for normally distributed, or I'm looking for a sample size of more than 30. So mean is 83.90 with a standard deviation of 1540. Well, this is the USDA. It is claiming a mean cost of 83.90 with a standard deviation of 1540. If I can work this problem, this is going to be a Z test because the standard deviation came from the same people who are making the claim. When I get down to the part that's about my sample, you believe this value is incorrect, so you select a random sample of 900 children and find that mean is 82.75. I don't have a standard deviation for my sample, so I am quite comfortable in my choice of saying this is a Z test. T test is if I have a standard deviation for my sample. Now my sample was 900. 900 is way more than what I need to be more than 30. So I can work this problem. It's going to be a Z test. All I have to do now is figure out my hypotheses so I can compute my p-value. The mean cost is 83.90 is my null hypothesis. What I'm wanting to test, is there enough evidence to conclude that the mean cost is different from 83.90? That means I'm actually testing to see whether it's changed, which means my claim is the alternate. Now I want to go to the Z test in my calculator. The 83.90 goes in for my null hypothesis. The standard deviation is the 1540 and it's a population standard deviation. My sample mean is 82.75 and my sample size is 900. I make sure that not equal to is selected for my alternate hypothesis, and then I tell it to calculate. I compute a p-value of 0.025. I'm comparing that in the problem. The problem said my alpha is 0.05. My p-value is lower than my alpha. That means I reject the null. If your p-value is low, you reject the whole. If I reject the null, I have to figure out what to do with my claim. In this case, my claim is the alternate. If my claim is the alternate, then I have to not use the word reject, I use the word support. So if I reject the null, I support the claim, and I don't know if I got enough room to write all this. That the mean cost is different from the 83.90. Number 2, the Better Business Bureau has received several complaints that a flour company is underfilling their 5-pound bags. The Bureau randomly selects 750 bags and determines the weight of each bag. The average weight of the sample is 4.8 with a standard deviation of 0.15. So, I'm talking about means since it says average weight. I don't have any percentages in here. If I'm talking about means, it's going to be a z-test or a t-test if I can work it. Well, since I have 750 bags of flour in my sample, I can work it. But, what kind of test? The average weight of the sample is 480 with a standard deviation of 0.15. That's going to be a t-test. Excuse me, because the standard deviation comes from my sample. So my hypothesis, the Better Business Bureau has received several complaints that a flour company is underfilling their 5-pound bags. Well, the null is always equal to, so the null is that the mean is equal to 5 pounds. The alternate, since we're talking about underfilling, is the mean is less than 5 pounds. So I do my t-test with those hypotheses. So t-test, the mean is the 5. The mean of my sample is 4.8 with a standard deviation of 0.15 and a sample size of 750. Now make sure you change the symbol. Oh, I did forget to mark. The claim is that they're underfilling the bags. So make sure you move the symbol for your alternate hypothesis or it'll give you a different p-value. The p-value I get here is flat out 0. There is no chance that the null is true. No chance. I didn't have an alpha, but it doesn't matter what the alpha is because alpha can't be negative. 0 is going to be lower than any alpha I could pick. So if p is 0, that means I reject the null. There's no way the mean is 5 pounds. And of course, this is just according to my data because I could have picked a bad batch of flour bags. So I reject the null. I support the claim, but I'm still only I'm not 100% sure that they're underfilling the bags. I've just proven that that is a definite possibility. So support the claim that they are underfilling the bags. Hush. Now if I scroll up the page, I'm ready for Bombay's Charlie. He's thinking about adding a certain spice to his curry, but he has to figure out if they prefer the taste of the chicken dish with the curry or with the spice added. So he's decided to add the spice if more than 80% of the customers like it. So since we're talking about percentages, as soon as I see that, it's not an average, it's a proportion. Proportion is one prop z-test. Now, to work a one prop z-test, I just need to do my hypotheses, because while there are conditions that we have to fulfill for a one prop z-test, until you get to a bunch of higher level statistics, it's not really relevant because all of our problems are going to meet those conditions. So if we write our hypotheses, he only wants to add the spice if more than 80% like it. So the null is just equal to. Alright, with that said, I do a one prop z-test, and on my calculator, I have to remember the reason that I wrote 80% as 0.8 is because that's the way I need to type it in. So even if you write it 80%, which is fine, make sure you change it to a decimal when you get to your calculator. So he had 65 customers in a taste test. 54 prefer the spices. 54 is your X. 65 is your N. Your N is your total sample size. Your X is always going to be the smaller number. Change your alternate hypothesis to greater than, and then calculate the p-value. The p-value here is 0.268 if you round it off. This is a p-value of up to 26%, 27%. You're never going to have an alpha that's like 30%, 0.3. Our level of significance is 10% at the highest. So I can compare with my alpha, but if you have a high p-value, that's automatically going to be fail to reject. Anything over 10% is fail to reject the null. Now, if I fail to reject the null, again, my claim is the alternate, so I'm going to fail to support my claim. The claim was that more than 80% prefer the spice. So what does that mean? Should he add the spice or not? Because that's the actual question. Well, if I failed to prove that more than 80% prefer the spice, and that was my mark for decision making, then no. No, the manager should not add the spice. Critical values, there's only one of three ways you could be asked this. We're always talking about a normal distribution. But the first thing you have to worry about is which tail you're talking about. If it's a two-tail test, we're talking about both tails. If alpha is 0.08, that means I have 8% total in the tails. So I have to split that in half for a two-tail test and say the right tail has 4% and the left tail has 4%. Now, critical values are z-scores. So I need a z-score here. To find a z-score from an area or from a percentage, I inverse norm. So I inverse norm 0.04, and that gives me this z-score over here, the lower one. and that's negative 1.75. If I want to find the z-score for the upper one, well, it's going to be 1.75 but positive. So I actually have two z-scores, positive and negative 1.75 if I have a two-tail test. Five and 6, more normal distributions again. I know, they're sad. Find the critical value of a right tail test. This is the right tail if alpha is 0.05. Alpha tells me how much is in the tail. Now I need to know the z-score for 5% in the right tail, which means when I inverse norm, I'm supposed to inverse norm the amount of the curve that's to the left of the z-score, which in this case is 0.95. So I can either inverse norm 0.95, which will give me my z-score with the correct sign, or I can inverse norm 0.05, which will give me a negative, but because I know I'm up here in the right tail, my z-score needs to be positive. The last one for the critical values, left tail test is down here. If alpha is 0.01, I just inverse norm my 0.01. That gives me a z-score of negative 2.33. The problems from Chapter 9. Chapter 9, I'll let you know when you're in Chapter 9, but it should be kind of obvious because you'll have two samples there. We have a random sample of 42 camp flashlights with brand 1 batteries, and they're given a sample mean. Another sample, that's how you know it's a 2 sample, with flashlights, 38 flashlights with brand 2 batteries. Now, as I'm looking through that, I see the sample sizes are both more than 30. So I don't need to see normally distributed anywhere in there. I'm good to go. But I haven't seen any standard deviations. When I get down to the near bottom, historical data from the companies indicate that that's a population standard deviation. That's a population standard deviation. So this is going to be a 2 sample z-test. The question is there a difference? When I'm just looking for is there a difference when I write my 2 hypotheses, I'm saying if they're equal to, that's no difference. If they're not equal to, that's different. So is there a difference means not equal to is the claim. Now I want to be careful here. Oops. Sorry, I meant to put the eraser. Well, it won't let me erase that. I don't know why. Anyway, let's just pick a different color anyway. We want to be careful here. We want everything that has brand 1. Let's do that in red. Brand 1. I did it again. I don't know why it won't let me erase anything. Alright, so I'll just use these big red blotches. Okay, so there's sample 1. Here's the mean of sample 1. Here's the standard deviation of sample 1. Sample 2, here's the mean of sample 2. There's a sample size of sample 2, the mean of sample 2, standard deviation of sample 2. Now when you go on the calculator under the 2 sample z-test, you got to make sure you get all this stuff in the right place. 2 sample z-test, first of all, the first thing it's going to ask you for are the standard deviations. So you want to make sure you give the standard deviations in order. Sample 1, then sample 2. Now I want to give the information for sample 1. Sample 1 has a mean of 9.8, and then it has a sample size of 42. Mean 2 was 8.1 with a sample size of 38. Make sure you change your alternate hypothesis to not equal to. And compute. And when we do, we get a p-value of 0.010. Our alpha is 0.05. Our p-value is 0.01, it's lower, so we reject the null. And our claim is the opposite, or is the alternate, so we use the opposite word. That's the way I remember it. Alternate hypothesis, use the opposite word. So if I reject the null, I support the claim that there is a difference. There is a difference in the lives of the batteries. So we go from batteries to rats. We're going to compare 2 growth hormones. Let's see if I can do this without messing things up. I have a sample of 10 rats with an average of 2.3 and a standard deviation of 0.4. The second hormone is a sample of 15 rats, which had an average weight gain of 1.9 with a standard deviation of 0.2. Now what I've noticed here is I've got 2 very small sample sizes. If I have 2 small sample sizes, I need to see something about the population having a normal distribution. The question is, was there a difference in the weight gain? So, my hypotheses. Same. Different. I'm looking for a difference, so the claim is the alternate. Now my standard deviations came from my samples, so this is going to be a 2 sample t-test. Same as the 2 sample z, except the things are in a different order slightly. In a 2 sample z, it really wants to emphasize the fact that your standard deviation came from someplace other than your sample, so it asks for the standard deviations first. In a 2 sample t-test, it's going to do everything from sample 1, then everything from sample 2. So it starts with the mean of sample 1 is 2.3. with a standard deviation of 0.4. Standard deviation of 0.4. Sorry, I made a typo. And the sample size was 10. Sample 2, average was 1.9 with a standard deviation of 0.2, and the sample size there was 15. Now, we have the correct alternate hypothesis already chosen, but on a t-test we are asked something about pooled. If we're told that population standard deviation should be considered equal, then we pool. We weren't told anything like that in this problem, so pooled is no. And then we calculate, and we get a p-value of 0.013 when I round. Alpha is 0.01. So 0.013 is slightly more than 0.01 because 0.01 implies 010. So since my p-value is slightly higher, higher means fail to reject the null. Which means fail to support the claim that the hormones work different. Now, remember, if this was a real study, I would probably do it again with a bigger sample size because this is real close to being a reject. And if you had more rats, you might get a different or a more definitive result. The very last one, I forgot. We don't have to do the very last one because doing a 2-sample proportion is not required. So if you have any of these that are 2-sample proportions, you get to just skip them. And I forgot about that till just now. So we're actually finished with the review, and I'll put skip on this when I post this to Shobi. I'm sorry I haven't been available. Wednesday night I went to the emergency room, and I've kind of been mostly drugged up since then. But we'll see what we can accomplish before the test tomorrow.